So differential equations. So this is the most important chapter of calculus part. So we have to give complete attention, and also we have to practice these questions very much carefully. And before practicing and solving question, we will require to understand the concept very deeply and very much comprehensively. So let's start with what is differential equations. So, what is a differential equation? A differential equation is simply an equation which have derivative of dependent variable with respect to independent variable. What is dependent variable? When we talk about y and x, so generally we write y as a function of x, where x is the input. So x is an independent variable, can be anything, and y will be dependent on x. So there must be a derivative in that particular equation of dependent variable with respect to independent variable. It can be in any other form also, but if we are considering y and x, y is dependent and x is independent, then there must be a derivative of any order, 1, 2, 3, or any order. There should be the presence of the derivative of y to x in the equation. Then equation will be known as a differential equation. So basically, it is a simple equation which includes a derivative. Is that clear?
Yes, sir.
Example can be x squared dy by dx plus 2d squared by dx square is equals to 0. So in this, we can see like there's a derivative of first order here and the derivative of second order. What is first order and second order? Is that the number of times we have differentiated the dependent variable with respect to independent variable. So now it is a thing to note that dy by dx should be in this form, and we'll be further talking about the differential equation more. So going in details, let's discuss about what is order and what is degree. So as I have told earlier, that order is the number of times that we have that we have differentiated the dependent variable with respect to independent variable. Let's say the dy by dx, the number of times we have differentiated y with respect to x. So order will be 1 when there will be a presence of dy by dx, and if there is a presence of d square of y upon dx square, so it means that the differential equation is having a second order derivative. And how it will be? So the order of this is second. Yeah. Okay. And what if this both are mixed in an equation like this? Then what will be its order? So the order will be decided on the basis of the highest order derivative which is present in the equation. So if the highest order derivative is of 2, so the order of the differential equation will be 2. And if there is a presence of higher order derivative in the differential equation than 2, then the order of differential equation, complete differential equation, will be 3. So this is how we can understand this. Clear?
Yes, sir.
And for calculating order, there are not much conditions, but when it comes to degree, so we need to be careful. Let's first understand. Yeah, so let's first understand what degree is. So degree is basically the exponent, the highest exponents of the highest derivative. Highest derivative means highest order derivative. There must be order in this one. The highest exponent of the highest derivative is called the degree of a differential equation, provided exponent of each derivative and the unknown variable, not variable, appearing in the differential equation is a non-negative integer. Okay, so basically, what is a degree? It is the highest exponential of the highest derivative. Simply, like let us say here, what is the highest order derivative? Is this? What is its degree? What is its exponent? Is basically one. So this will be a degree, provided that the exponent of each derivative, the power of each derivative, and unknown variable appearing in the differential equation is non-negative integer. Like, should be a natural number, form of natural number, and the differential equation should be made free from radicals and fractions of derivatives. Means that if its power is in fractions, then it should be in integer format. If it is having some radicals attached, means if the function is attached to any logarithm or trigonometric function is there to attach to these derivatives, then we'll not be able to find out its degree. So basically, we will be able to find out the degree of differential equation, which will be in the format of polynomial. The differential equation must be a polynomial in derivatives. Means that the derivatives must be having powers and they must not be attached to any radicals like logarithm or tan. Okay, here we'll
Yes,
better
sir.
understand it using examples. Let's take an example where the differential equations derivative are having radicals. Like for example, sine of x d square y by dx square plus cos of dy by dx square 3. So if this is a differential equation, now we can see here the differential equation is having derivatives. Yes, but it is attached to, sorry, yes. So here, this is attached to radicals like trigonometric functions are there. So these are not independent. The polynomial is not in the form of derivatives freely, independently. They are attached to these trigonometric functions. So now here we will not be able to find out degree. Degree will be not defined. But if we have to find out the order of this differential equation, this will be simply what? What is the highest order derivative in this differential equation?
Mm.
Yes.
Co- Cos dy by dx.
To
Oh, it's two.
order means the number of times the y is getting differentiated. So
Okay.
here the number of times is 2. Here it is the power 3. So it doesn't mean that it is getting differentiated 3 times. It is just that it is differentiated 1 times and then its exponent is 3. Okay. Let's take more examples. It will be clear. So d square y by dx square plus 2y plus dy by dx raised to power 6 and whole raised to power 1 by 4. Now the problem here is find order will be simply found out by simply observing the derivative. The highest order derivative here is,
Is it again two? No, I couldn't exactly.
okay, that is 2,
Two.
but
Okay.
let's make you more clear about order. So if there is any function, let's take f of x. If we are differentiating it once, then how we will write it? We can write it in this format, or we can just write it like this. So this is first order derivative. Means that we have derivated it for the first time. If we further derivate it, so it will be written as 2 by dy square and, sorry, we are differentiating it with respect to x because it's a function of x. If it is differentiated twice, so we will write 2 here and write 2 here, that means that we have differentiated it once again. It means that we have differentiated this with respect to x once again. So the original function was f of x. Its first integration of, sorry, first differentiation happened, and second differentiation happened. To represent this, we were representing it like this or in this format. So it means second order derivative. And if we differentiate it further, or it can be represented this manner. This is third order derivative. Is this clear? And this goes in on and on.
Yeah, sir. Till this I'm okay.
Yeah.
Yeah, sir.
Yes. So here the order is 2 because it is the highest number of times the y is getting differentiated. Here is 2 and here is 1. So the order is 2 of the differential equation. Now we're finding out the degree of the differential equation. We need to first sort out the exponent. So here the exponent is in fractions, which is not allowed. So what we'll do, we'll try to square it. We will try to raise the power of both sides by 4. So raising the power of left hand side to 4. And when we will raise its power to 4, 1 by 4 into 4, that will become 1. So now the power of all is in integer format. So now let us find out for its degree. Degree of what? Degree of highest order derivative. Here is, what is its degree? Please answer, don't hesitate. No problem if you give any no.
2.
No, its degree is 4 because degree is exponent. Here the exponent of this particular term is 4. So degree is 4. Okay.
Okay.
Let's go back to the definition and once again understand. The highest exponent, degree is the highest exponent of the highest order derivative. It's called the degree of a differential equation, provided these conditions are there, that the power should not be in the fractions, it should not be negative, and as well as the derivative should be free from radicals. These are 3 conditions. Let's take more examples to better understand it. Next example is y is equals to e raised to power e dy by dx plus d2y by dx square. Okay, this is the function given. So now there is a radical attached to our derivatives, but if we can solve it, that's no problem. So let's try to solve it first. First example, third example. So we know about logarithm and we written as like this. Okay. So here logarithm y, we have basically taken log on both sides. Okay. We're taking log on both sides and to the base e. This is a natural log. So this will become, if this is a logarithm of e to the e raised by something, so the power will come at dy by dx plus d square y by dx square into logarithm of e into e, which will basically becomes 1. So this is now the modified differential equation, which have derivatives, but and the constant part is having some radical, so it doesn't matter because it's not attached to a derivatives and of which we are concerned about. So here the order will be, tell me what will be its order. What is the number of times the y is getting differentiated? 2, right? The degree will be some terms power is not written, so its
Yeah.
power is 1.
1.
Yes, so its power is 1. That's why its degree is 1. Taking more examples, sine of dy by dx plus d square y on dx square is equals to y. So now here also there is a radical attached to our derivatives, but we can try to separate it. So we can bring the sign on the right hand side. So it will become an inverse trigonometric function and our radicals are now set free. Now here on observation, you'll find out that the order is
2.
yes, and degrees.
1.
Okay. Taking next example, e raised to power double derivative of y. Sorry, triple derivative of y, which is represented like this. Okay, this means dy by dx, and this means d2y by dx square, and y this means triple dash means y is getting differentiated 3 times. Okay, so the given differential equation is plus y is equals to 0. So now here from the equation itself, we can see there's a radical attached to our derivative. So order can be written of any differential equation. Order is basically 3, but the derivatives, let's try to first separate the radical from the derivative. So e raised to power this equals to x y double dash minus y. If we will try to take logarithm here, so logarithm will be here and then e will be gone. But the problem will be that this is also a derivative. So there will be still a radical attached to derivative. So we will not be able to find out the degree of this particular differential equation. We will write it as not defined. Is this clear?
Mm. So could you explain it once again because I couldn't understand it?
Sure, sure. Okay, so taking once more, I think here, e raised to power third order derivative of y minus x multiplied by double derivative of y plus y is equals to 0. So this was our differential equation. The order is basically the highest order derivative present in the differential equation whatsoever. So here if we observe, this is just a variable, this is the second order derivative, and this is third order derivative which is present. So order will be
3.
good. And the degree, for finding degree, we have to set the derivative free from radical. So here we can see there is a derivative, this is the derivative of y, which is attached to an exponential function. This should not be the case in polynomials. So we'll try to separate this from E. So how we will do that? For solving exponential function, we generally take logarithm. So let's first separate this by writing it on the left hand side and the remaining terms on the right hand side. So this is now the right hand side, this is the left hand side. So for solving this, we generally take logarithm as we have done in earlier questions also. So I'm taking logarithm e raised to power by logarithm x y double dash minus y. So e logarithm to the base e and of e will cancel each other and will simply become this. So now this derivative is set free from any radical. But now we can solve this further. This will be remain like this only. So now here there is a derivative in logarithms inside input variable. So this form on this right hand side in this differential equation is having some radical in form of logarithm function. That's why we'll not be able to find out its degree. Degree will be not defined. Clear?
Yes.
Okay. So Shall we take some more examples? Let's take some more complicated examples, because order and degree topic is really very important, and it's not that complex also. If you just want to understand it, it do not require any great knowledge and any great time to solve this kind of question. And at UPSC and DA examination, it has been seen a trend in that examination that question from this topic is always asked, always asked. dy by dx plus 4y is equals to cos x. So the order of this is, please unmute yourself and speak. Speak, speak.
So
Order and degree of this differential equation.
that is no, like in the first one, dy by dx plus what is that? Said 4y.
Yes, that is 4y.
Order will be 1.
Yes, correct,
Degree is also 1.
correct. Order and degree of this.
Order is 2, degree is 5.
Order is 2, degree is 5. No, the degree of highest order derivative. Now tell me.
Okay. Then it's 4.
Yes. And whenever we are discussing about degree, so then it must be of highest order derivative, right? Anish, do you have any doubts? Anish, I guess he's sleeping. Now the degree of this is degree of this. First, let's talk about its order. Its order is what?
2.
Its order is 2. Yes, right. And degree is
1.
yes, right. Let's go to some complex examples now. Noted. Order and degree.
Order is 1.
Order is 1. Very good.
Degree. Degree is also 1.
How?
Mm,
How degree is 1?
No, there is truth, but I'm not exactly.
No, but still, tell me about your according to your logic only. So,
We don't have
well,
any degree for the whole thing, no, sir. It's just a square d y. It's then it has degree for separate numbers, no. So I thought.
okay, so for this kind of equation, according to rule and according to, as you have talked earlier, that the derivative should have a positive, should have a non-negative integer as its exponent. But what is happening here? There's a square root. So the power is in fractions, right? So we have to
Okay.
simplify it further. For doing that, we'll bring this term to the left-hand side,
Okay.
and this will be written like this into a square into dy by dx square plus b square. Now we'll square on both sides. This will become
Whole square.
square root will be gone.
Okay.
So now, as this is a simpler form, we'll expand this form also. The power of dy by dx, that is the highest order derivative here in this case. So as already we have discussed, the order is 1.
1.
Order is 1. And here degree will also be 2 because degree is highest exponent. So it cannot exceed 2. Degree will also become 2.
2.
This is a example which is good to improve our understanding. Okay, understood?
Yes, sir.
Check one more example, then we'll go ahead. Two minutes to solve.
Okay. Sir, one doubt.
Yes.
Sir, do we calculate the LHS also?
Um. What do you mean?
No, sir. Means the left hand side d square y. No, now the order is 2.
Order is 2. Yeah, correct.
Hmm.
Degree?
Okay. Degree is 1.
Degree is 1. Really? There's this exponent is in fractions, right?
Ah, yes, sir.
So what will you do? Please guide me. What should I do now?
Mm.
What
Do
should
I
we
have
do?
to expand it or?
Yes. But the power is in fraction, right?
Yes.
So we can square both sides. So
Then 2 will get cancelled. No.
yes, here will be 2 and here also
Ah.
the exponent will be 2. This will get cancelled. Now
Yeah.
the power is in integer form. So now tell me what is its degree?
It's 3.
It's 3.
Sorry. 2, sir. 2, sir.
Highest degree of completion.
Highest, yeah,
Oh,
that's right.
yeah. Great. So its degree is 3. So I guess we are clear now. So radicals are just any trigonometric function. Can be trigonometric functions or logarithm or exponential function. If they are attached to a direct derivative, then we will not be able to find out its degree. Otherwise, it's good to go. Even if there is a let's say d square by y dx square and so on, and in the constant form there is sin x. If it is not attached to derivative, so no problem, we can still find out its order which is 2 and derivative which is 2. Sorry, degree which is 1. Yes, so its order will also be 1 and degree will be 1. Sorry, order will be 2 and degree will be 1, right? Clear? Yeah. So let's move ahead and discuss about formulation of differential equation. To form a differential equation, yeah.
In the previous question, you wrote degree is equal to 3. Means not this one we have.
Yeah. Mistake.
It's 2. Okay, only that.
Yes. Good. Formulation of differential equation. To form any differential equation, we will first differentiate whatever the given curve or the function is, and then we also have to eliminate the unknown constants. We will do so if they are like in the previous slide, we were also discussing about the constants. Yeah. So parameters are also known as arbitrary constants. So if the given function of the curve has some arbitrary constants, then we'll have to arbitrary constants will be in format of alphabets. It can be represented by A, B, C to Z. Any alphabet which is not a variable, but it is a constant. So we'll have to eliminate those. So for eliminating those, we'll have to differentiate the given function as many times. We'll have if this is a function, we'll have to differentiate it as many times as of the number of arbitrary constants present in the function, present in the curve. Okay, we'll have to differentiate the given function as many times as it is having the number of arbitrary constant in the function to eliminate all of those, right? Let's take an example and then we'll be able to understand it in better moment. Yeah, so let us consider there is a function given of circle. There's an equation given of circle function x square plus y square plus lambda of y. I hope the background noise is not coming, is it?
No, sir, I couldn't hear any noise.
Oh, great. So this is the given equation of family of circles, and we have to find out the differential equation touching x-axis at the origin. So it is given that the function the circles are touching x-axis at the origin. Okay. Let me write somewhere. Find differential equation of family of circles touching x-axis at the origin. So this is our question. This is just the question. Now from the question we'll make out that such family of circles touching x-axis at the origin should have the general equation as of in this format. We'll be better understanding that how this equation will come out when we will study conic sections and when we'll study circles. Okay. So it's just that we have an equation of a given circle, and of this equation, we'll have to find out the differential equation. Now, from the given equation, we can make out there is only one arbitrary constant. X and Y is what? Please tell me what is X and Y. Is this a constant? Is this a variable? What is this?
Variable.
Variable. So it is a variable. So what is constant in this equation now?
Lambda.
Yeah, lambda, which is one only. There are no other constants. So how many times will you have to differentiate? How many times you have to differentiate this? As same number as the number of arbitrary constants present. So how many constants?
1.
So only we have to only differentiate the given equation one time. With respect to what? X. Okay. So differentiating this particular equation on both sides with respect to x. So differentiation of x square becomes 2x. Now the differentiation of y square, 2y, multiply the differentiation of y using a chain rule. Lambda into differentiation of y, because lambda is a constant. Differentiation of 0 is 0. Now that we have a differential equation, we'll have to eliminate this constant. We'll do so by putting or substituting the lambda's value from the given equation. So simplifying the equation, x square plus y square is equals to minus of lambda y. Come on. So x square plus y square is equals to minus of lambda y. Then we'll separate lambda and y on both hand sides. On left hand side, we'll have all the variables minus lambda y and x square plus y square upon minus of y will be equal to lambda. So now we have the value of lambda. So we can take here 2x plus dy by dx common and 2y plus lambda. Lambda is what? Minus of x square plus y square by y is equals to 0. So now that we have a differential equation, which is free from every what should we say, every arbitrary constant, right? We can also better represent it. Yeah, so we can also solve this further. Dy by dx into equals to, we have brought this 2x in the left hand side, minus of 2x. Solving this, taking y as LCM, 2y square minus x square minus y square minus y square. So solving this further, this become dy into dx, y square minus x square upon y is equals to minus of 2x. So dy by dx, multiplying y on negative, sorry, multiplying this under this cross multiplication, y square minus x square, y ahead, y on the numerator side. So dy by dx will become, will multiply this negative sign on both numerator and the denominator. So the numerator will become 2xy upon x square minus y square. So this is the differential equation of the family of circles touching x-axis at the origin. Touching x-axis at the origin means that basically for y is equals to 0, x will also let's put it in different manner. The circle is touching the x-axis at origin. So it means that the circle center will not be situated will not be situated on the circle will be drawn something like this. Okay, so it is touching the x-axis here. So basically the center will be h and k, where the with the value of x will be 0. So when the equation of general equation of circle, this is extra, I should not discuss about, will only confuse you. We'll expand this form. So h is 0. That's why there is no other term of x here. That's why only there's a term of y which is having a constant terms. So that's how you can make logic. That's how we have written the equation. You'll better understand it after discussing conic section. Okay.
Hmm. Okay, sir.
Yeah. So let's discuss one more example. In that, we have to formulate the differential equation of the following relation. First, we'll have to find out the differential equation of this. X square plus y square is equals to 2ax. So, how many arbitrary constants are there in the differential equation?
Mm.
How many arbitrary constant or how many parameter is there in the differential equation?
One is 2 and another is a. Whether I have to say it 1 or 2.
It's one only. A
Okay.
is the only alien here. Otherwise, x and y are the variables. So we have to differentiate it once only. So differentiating on both sides with respect to x, differentiation of x square is 2x, 2y into dy by dx. Because here, if we have multiplied dx by dx, that has become 1. So insignificant to write. Is equals to 2a. Differentiation of x has become 1. So now, solving further, now we have to eliminate this parameter's value. We'll use the given equation, x square plus y square by x into 2, the value of a. We'll use it here, and that will come out as x square plus y square. 2 will cancel 2, so this has become this 2x plus 2y into dy by dx. Now solving this further, 2y into dy by dx, x square plus y square upon x minus 2x. After taking LCM, it will become minus 2x square. So the right hand side will become y square uh, minus of x square upon x. So dy by dx will become y square minus x square upon 2xy. Okay, clear?
Yes, sir.
Yeah. Let's take one more example. We have to find out the differential equation of this equation. Now, how many parameters are there?
2.
Please respond.
Is it?
Yeah.
Is it 2, sir?
Yes, there are two, A
Hmm.
and B. Okay. So we have to differentiate it 2 times. Let's differentiate it once first, differentiating both sides with respect to x. So 2x plus 2y into dy by dx. 2a into differentiation of b is just 0 because it's a constant. It is not changing with respect to x. Now further differentiation of this to differentiation of, now there will be a, this is y into dy by dx can be written as this. So this is a product of the two variables or the two functions which are dependent on x. So we'll follow product rule for that. What was our product rule? If there are two functions which is dependent on the variable x, so we'll first multiply the derivative of first to the second, then we'll multiply the derivative of second to the first. That was the rule. U dash v plus uv dash. Uv dash, sorry, it's one dash only. So now here also the derivative of first into the second function, which is y dash only, plus u, which is y, the derivative of second. Differentiation of dy by dx differentiation will be second order differentiation. If we will differentiate this term once again, so it will be a double order derivative. So this has become y dash square plus y into y double dash. Now please do not confuse that y dash square and y double dash are the same thing. No, they are not. This is dy by dx whole square and this is d2y by dx. Okay, they are two different things. This is first order derivative square. This is simply the second order derivative, right? Clear?
Yeah, sir.
Okay. So now the differentiation of this is y dash square plus y into y double dash is equals to 2 no, now the differentiation of 2a is simply 0. Okay, so this is now our required differential equation. This is the answer only. We can also represent it further by taking plus 2 in that direction. Okay, how will do so? Simply it will become minus 2, then 2 will cancel each other. That's 2 there. Minus 2, 2 cancels 2, y dash square plus y into y double dash minus 1. This is also our given. This can also be written as the solution, but that depends on what options are there. Okay, it always depends on the options. Have to choose one, have to go with that. Okay, clear?
Yes, sir.
Taking one more example, y is equals to ae x plus b e raised to power 2x. Now that there are how many parameters are there, how many arbitrary constants are there?
2.
So we'll have to differentiate it how many times?
2 times.
Differentiating it first, dy by dx plus constant into exponential function. Differential from ex is ex only. So the differentiation of e raised to power x is ex only. It's a very stubborn function, exponential function. Okay, so now the differentiation of this b, its differentiation will remain the same. Here is the derivative. The differentiation of 2x is 2. Okay, that's now differentiated once again. Differentiation of this will remain the same. Differentiation of e raised to power x is e raised to power x plus b into differentiation plus 2b to differentiation of this is e to the power 2x. Differentiation of 2x is simply 2. So simplifying it, you can write it as 4b e raised to power 2x t2y upon dx. The only task remaining is that we have to eliminate a and b, right? Right?
Yes, sir.
Yeah. So how we can do that? One option is yeah. So this can be represented as it will be e raised to power 2x. So we'll try to eliminate from here. So y minus e raised to power x has become be to x, right? So here here b will be eliminated. Let's first focus on b only. So b raised to power 2x is y minus raised to power x. So this has become 4y minus 3 raised to power x. Clear till now?
Yes, sir.
So we have successfully uh, eliminated a. Now let's eliminated b. Now let's focus on a. For that, let's use this. Let's use this equation, which is y dash is equals to a raised to power x plus 2 b raised to power 2x is what? Y minus a raised to power x. So y dash will become 2y minus of a raised to power x, because plus 2, sorry, plus 1 minus 2 will make it minus 1. So now from here also we can take the value of a raised to power x, y dash minus of 2y will become minus of a raised to power x. So this is one equation which we have used, another equation which we have used. So now this can be represented as y double dash 4y simply minus 3 into plus 3 into minus of a raised to power x, which we can uh, eliminate with this. So now there are no arbitrary constants left in the equation, right?
Yes.
Right?
Yes, sir.
This can be written as our answer. This is our answer. Okay. We can better represent it by further solving it, but it will be done on based on what options we have. So this topic is known as formulation of differential equation, where we will focus first on how many arbitrary constants are there. Then what we will do, we will differentiate as many times as the constants are present there. And then what we will do, we will eliminate the constants, the arbitrary constants in the final differential equation which we have solved for. Thereafter, we will have to match it with the options. We will modify it with the options. If the option is matching, then that particular option is the correct, and take that and we'll get plus 2.5 marks. Correct. So is everything clear about today's class, what we have discussed?
Yes, sir.
About what are differential equations, what is the degree, order, okay, and formulation. Spelling, my God. Okay, so differential equation, order, degree, and formulation of differential equation. Tomorrow we'll be discussing about solution of differential equation. I advise you to uh, like remember and recall integration formulas before tomorrow's class. So because there will be integration, there will be use case of integration multiple times in tomorrow's class. Okay.
Okay, sir.
Yeah. Any other doubts?
No, sir.
Okay. Yes, Tanish. Please unmute yourself and do not raise hands because I'm not able to see them.
Sir, can you teach a simple sum for order and degree? One sum, sir.
Simple?
Simple one sum, sir, for finding order and degree.
Yeah, for sure. I'll repeat. So, is my screen visible?
Yes, sir.
So, what is a differential equation? Differential equation is basically any equation which is having derivative in it. And basically, differential equation is a polynomial in forms of derivatives, right? And derivative of what? Derivative of dependent variable with respect to independent variable. What is a different in case of y and x? Usually we have y as a function of x. So y is dependent on x, whether x is independent. So dy and dy by dx must be in the differential equation for that case. Clear? Please unmute yourself and respond. Keep responding.
Sir, can you repeat it?
Yeah. So differential equation is any equation which is having a polynomial in its derivative form. And derivative is what? Derivative of y with respect to x, where y is dependent on x, right?
Sir,
Yeah. So it's a polynomial, it's a simple polynomial. It's an equation in dy by dx that will be known as an differential equation, right? Clear?
yes, sir. Sir, I ask you to teach how to find order and degree.
Yes, sir. Yes, sir. Doing that. But before that, I will first explain differential equation. Clear?
Yes, sir.
Yeah. So now coming to order and degree. Now the highest order derivative which is present in our differential equation will be the order of differential equation. If the order of this is 1, the order of this is 2. So if there's a like a differential equation having multiple different kind of order derivatives in that, so we will have to refer to the highest order derivative which is present in the differential equation. That will be considered as the order of differential equation. Here, in this case, the order of this differential equation is 3. Correct. Clear? What is the order of differential equation? Tanish?
Yes, sir.
Yeah. So talking about degree. So for degree, there are certain conditions, but first let's understand it in simple language. Is that the highest exponent? Exponent is what? Power, which is written in like 2's exponent is here is 3, 2's exponent here is 100. So the exponent of the highest order derivative, the exponent of highest order derivative. Let me correct the text. The highest exponent of highest order derivative is called degree of differential equation. As in this case, the highest order derivative was this. The highest order derivative was this. And its degree, its exponent was 1. So that's why the degree of this particular equation, differential equation, will also be 1. But there are some certain conditions to consider. That the derivatives in the differential equation must be free from any radicals. First condition is derivatives must be free from radicals. What do I mean by radicals? Is that there should not be a function of there should not be a trigonometric function there. It should not be involved in trigonometric function. These derivatives, they should not be involved in inverse trigonometric functions or logarithm or exponential or any sort of function. They must be just in polynomial form. And the power, the degree, the power of derivatives must be non-negative integers. Integers are what? 1, 2, 3, 4, 5, 6, 7, 8, and also the negative ones, but we are excluding those negative. Okay. So these are two conditions. And yeah, so these are two conditions only. And the power of the derivative must not be in fractions. So as we have written this, that the powers of derivatives must be an integer. Clear? So the degree of the highest exponent, the highest exponent of highest order derivative is called a differential equation. Well, let's take some examples. Where, as you can see, the derivatives are bound to some trigonometric function. They cannot be separated from these. So the degree here will be not defined. The order will be 2 here. Here, the derivative is the highest order derivative is 2. That's why the order is 2. But second example, this is same question. But the power, the exponent of the derivative here is in fractions. So we'll have to solve it. How we will solve that? We'll bring this power to the left hand side and this will become an integer right now. So here the degree for the highest order derivative is 4. That's why the differential equation is 4. Clear? Yes, Tanish.
Yes, sir.
So clear about order and degree?
Yes, sir.
In other examples also, please first try to separate the radical form from the derivatives. And if you are able to successfully separate, then you will be able to find out its degree and order. And if you are not able to do so, then the degree will become not defined, like in this case. Like in this case, when you will not be able to separate the derivative from its radical, right? Clear?
Yes, sir.
Okay. So please join the class on timing so that you will not have any doubts on backlog sleeps. Okay?
Yes, sir.
Yes, I'll conclude today's class. Everyone,
Yeah, sir.
thank you, Jain.
Thank you, Sir. Jai Hind.
Thanks, sir.